Hello everybody! If you've been on the call for the past few minutes, I'm sure you are well and truly over the Mariah Carey Christmas songs playing in the background. But it is the festive season after all, so I figured why not have a bit of fun. Hopefully you can all hear me and see me. It's office hours number 315, believe it or not. That's how many office hours we've done since its inception back in, I think it's February 2018. So thank you very much. I think, don't quote me as a gospel, but I think this is the very last office hours for the year. So very much appreciate you joining me. Let's share my screen. Let's get something going and we'll get into it. That's probably the best way of describing it. So let's do that one. So hopefully you can all see that and everyone's cool. I'll bring up my little chat window as well, just in case people want to throw things in. Seeing it if you can't see that, as I always start every session, we have how to get in touch with me because I do enjoy talking technology. That's my Twitter handle, Connor McDonald, and obviously because depending on where you're joining us, there are lots of different ways of people prefer their social media. You can get in touch with me via Linktree/Connor. That way you'll get my blog, my Twitter, Facebook, Instagram, LinkedIn, etc., etc., etc. As I always say, do not adjust your set. All the slide content will generally appear at the bottom left of the screen because in that way, when we turn this into a YouTube video for your viewing pleasure, you'll be able to see the host, namely myself, chatting away in the top right-hand corner. As always, I like to start with some bits and pieces, things that I've been doing and things that are coming up, just so you're kept abreast of what the Oracle database advocates and the like are doing around the world. So the first thing is, at the start of December, I went to UK OEG. That's a picture of sunset of Brighton. It was cool. It was the first time I think the UK OEG conference has been in Brighton. I lived in Brighton for a year when I lived in the UK way back when, so it was lovely to go back to Brighton. Really successful conference, and I think a good measure of the fact that conferences nowadays seem to be moving to, what's the right term? Maybe I'd say more exotic venues, in the sense of rather than trying to get big conference halls where I think there's a bit of a stagnation. There's just so much going on, but it feels like you're sort of in a massive auditorium. The conference in the UKG was of similar scale, but all the rooms were generally sort of function rooms inside a hotel. So they felt smaller, but also more cozy, more enclosed. Often a lot of the talks had standing room only. Maybe not such a good thing for attendees, but I think it created a much more warm atmosphere. People were much more keen to talk, much more keen to interact, as opposed to those events where you still have the same numbers, but the room holds 5,000 people, and so people are scattered, 5 rows apart. Here, people were all, pushed in, occupying every seat, which I thought was really cool because it just created a really much more community feel to the conference. So, kudos to the UKOG guys. That was pretty cool. Straight from UKOG, I went to the Sangam conference, Indian Oracle User Group's main event of the year. Getting upwards of several hundred, in fact, nearing 1,000 people when you add up all the volunteers, etc. Fantastic event. That picture I put on the screen, I put up there because I wanted to put that as a bit of a call to arms to anyone on the call. Let me hold this up. Hopefully you can hold this. Let me put that there. We go. Oh, how's the camera going to go with that? Okay, so hopefully you can see that in the little picture of the Zoom window of them. That is a book. Now, why is that book significant? No, I didn't buy it, and no, I'm not saying you should buy it either. What I'm saying is it's a measure of the fact that this group, Doyen Sis, who are one of the sponsors of Sangam, sat down with a group of their employees and said, the best way to learn about a piece of tech is to write on it, because you have to research it, you have to explore, you have to test it. So you can see, if I hold this up again after the camera, you can sort of see that we actually had 4 authors on this one, but they had 6 books all launched at the Sangam event. I think each one had about 4 authors. And the beauty there was they'd set themselves a task of how do we make our employees stronger in tech, stronger in knowledge, and stronger members of the community. And they said, let's write books. So they had 6 books. I was privileged enough to actually do the handshake and the launch for one of them. There were 5 others that other speakers launched as well. But that's a bit of a challenge to anyone on the call or anyone in the community. It's a great way of saying it's not enough just to attend conferences. It's not enough just to do your job. Why don't we make ourselves, immerse ourselves in the tech? Let's further ourselves. And they chose to write a book. You could do it by writing a blog, doing a video, doing something. But I thought that's real kudos to the guys and girls at Doyensis. I thought that was a fantastic initiative to actually produce 6, hard copy books in this thing. Fantastic, awesome stuff. What's coming up for me in January? I'll be going to the Italian Oracle User Conference. The bit.ly link you can see on your screen. That's my little promo video there. The only reason I'm putting it in there is because I did it in Italian. Now, I should say, let me be accurate. I did it in really bad Italian. It's probably the better way of describing it. But yeah, so if you want some fun and seeing me bastardizing the Italian language, you can go to that link, bit.ly ItalyConf, where I did a little promo video. But obviously, if you're in Europe, hopefully you'll be at the IT OUG Tech Days. There's a really good array of speakers coming up. And I'll be going straight from there to the Israel Tech Days. And once again, similarly, it's a fantastic event coming up. They do a fantastic job running that event. We always have great numbers, but there's a great array of Oracle and non-Oracle speakers as well. The agenda, I think, has just gone live. So please check out those 2 events. And if you've never been to Israel, I can highly recommend it. It's a fascinating country. What are we doing tonight? It's part 2. Now, why I call it part 2? Because part 2 is last month, I wanted to talk about the mistakes that we often make in using our Oracle technology, and I just ran out of time. Regular callers on the DBA office hours will be thinking, yeah, no, surely you didn't run out of time, but yes, I did. We ran out of time. So I thought I'd simply continue on. And what better way to celebrate the end of the year by talking about all the stupid things that we do? And I figured, why not? Let's do that. So before we start, as I said last week, but I'll keep this, or last month, I'll try to keep this brief, a little moment on the soapbox of myself. Why talk about failure? Because there's one reason is no one does. And I think this is a really sad thing. It's like, if we constantly talk about the right way to do things without context, don't get me wrong, best practices and stuff are often good. But if we talk about the right way of doing things without the context of here's how we discovered the right way of doing things, here's how we messed up, then ultimately those talks often are purely about a demonstration of how clever the speaker is, or how clever the blog post is, or how clever the code is. But it doesn't really set the context, doesn't set the background as to why and how we arrived in that. Whereas failure helps us all because it often serves as a cautionary tale. And I like to think of talking about failure in tech as similar to talking about the kind of dudes we do as parents or as friends or as colleagues. We often say, don't do that. I tell my children, don't touch the stove, it might be hot. Take your brother out of the microwave. No, I'm just kidding. But effectively those kind of things. It's cautionary tales that often give us the experience and knowledge that actually drive us to become better individuals at whatever field we're trying to pursue. And I stressed failure is not necessarily of negligence. Often failure really just becomes down to poor decision making. And it's actually this slide here. Poor decision making was actually the thing that motivated me most in terms of putting these talks together for office hours, because as you've no doubt heard over the whole past probably 18 months, we have a changing role as DBAs, even as developers. You've probably seen the 7 million slides about autonomous offerings coming from Oracle. A lot of the mundane, the stuff that we hated doing as DBAs, is thankfully being taken off us, taken off our plate nowadays, which means the people we work for, the businesses we work for, the customers we represent, the IT organizations that we support are really saying to us as DBAs now, what's the best way of doing things? How should we tackle this problem? And so we have a decision-making role now, and often poor decisions are the thing that create problems when it comes to building applications on the Oracle database or looking after the Oracle database. Ultimately now, as DBAs, we have an increased level of responsibility, which I think is a great thing. I like the fact that as DBAs now we're having that opportunity finally to be more invested in the success of the businesses that we work for. Now, as I said last month, this is not a witch hunt. We're not going out there going, here's some code from a particular place, and here's the person that wrote it, and here's where they work, and aren't they a numpty? I have some real code examples here today, but obviously the sources of which will remain nameless because it's, as I said before, we're looking at learning and growing and prospering together. So let's get into it. Okay, here's a mistake that is very common in the workplace, what I call excessive work. And I wanted to talk about this one because this is one of my favorite horror stories. I call this my all-time classic of just how far off track we can get with all good intentions. And this is the code I would like to walk through. And we're not going to walk through it in bulk like this because it's just hard to actually comprehend. We're going to break it down in little pieces. But you can see there at the top, this procedure is called string check. Now, let's break down the code to actually into simple small chunks to actually see what this particular routine is doing. So I focused here on lines 12 through 18. And what it's actually doing, it's going from 1 to 45, and then you can see on 16 from 58 to 255. Those numbers are significant because if we map them to the ASCII codes, 1 to 45 and 58 to 255 is all the characters in your standard ASCII character set that don't include the numbers. So we're effectively building a string here of about 240 characters long, which is all the characters except the numerics, except 0 through 9. If we go look at lines 19 through 22, we had this list now of 240 characters. We're going to iterate through each character, and to extract each character, what we're going to do is do a select substring from Joule to actually get the first character, the second character, the third character, etc., etc. Once we've got that character, we then go look at our incoming text. So line 9 there is the text that's coming in. We're going to look inside that text for the particular character we've just extracted from the previous slide. So see if that character is found inside the incoming parameter called pText using an in-string from Joule. Now already you're probably thinking this seems a bit odd, like what is the function here? So we finally get to the end of the thing, which is if we did find any occurrences of particular characters, we return a 1, otherwise we return a 0. So as I said, that's a very quick run through a code if we're doing a code review. So let's actually see what it's actually designed to do. So to help us out here, I thought I'd actually show the code flow with a little bit of PowerPoint animation. As I said, this is the character list we've built. It's all the characters except the numbers. So I've truncated it here, but you get the idea. It starts with a space, and then we've got the caps, the lowercase, and then all the symbols, all 255 US7 ASCII characters minus the numbers. And someone calls string check 178. So the first thing I do is I take that 178, that's my incoming parameter, and I say, let's get the first character from character list, that's the A. And then I do an in string, is there an A in 178? Yes or no? And then I get the second character, that's B. And then I run an in string, is there a B in 178? Etc, etc, etc. Did I do 3? I did. So then we use C. Is C in 178? And we continue on and on and on through the entire string. Now, what is this doing? What is the purpose of this function? Once we've gone through all those characters, we actually send a return value. And so when I ran this function to see what was going on, if I call string check with 1, 2, 3, it returns a 0. If I pass a number, I return a 0. If I pass something that contains a non-numeric digit, it returns a 1. Yes, it is a check if the input is numeric function. That's how someone wrote this. And that was my first question. In fact, to set the tone here, I got asked to come in to visit a customer to see because they were having enormous CPU performance problems. And this is what was. Effectively, this function that was built was used everywhere. They had a number of external systems that were providing information to them, And for every fragment of information that provided data, and some of that data needed to be numeric, they would call this string check before allowing it into their system. It was a data checking cleansing routine. So every execution was doing 244 select substring calls from Joule and 244 select in-string calls from Joule. And even putting aside this code, this is actually a really common coding error I see. A lot of people think that to do simple arithmetic expressions in PL/SQL requires a select from Joule. And I think this is a hangover from the days where you couldn't get things like sequence numbers directly in PL/SQL. So people would do, if I can't get a sequence number, I have to do select sequence number next vowel from Joule. So therefore, if I need to do a substring, well, I might have to do a substring from Joule, an in-string from Joule, etc. And it's funny, this is what they were observing. They said, we are having all sorts of problems. Our machine is absolutely pegged to the wall with CPU, and they couldn't work out why. And funnily enough, that's why they called me, and I went in there to help them out. And this is a common query I run when I get called into a sort of a customer site blind. They're saying, we got problems, what do we do? Well, unless there's Oracle bugs, the vast majority of all performance problems are due to bad SQL. So if your CPU is getting maxed out, the most common thing you will look for is what are the queries that are running the most logical I/O, which is buffer gets, because buffer gets pretty much is a mapping toward CPU consumption in the Oracle database. So I run this typical query, SQL text buffer gets executions from $SQL stats, buffer gets greater than a million. Quick sidebar here, if you currently have queries that query $SQL, generally a drop-in replacement is $SQL stats. There's also a $SQL stats with child, I think, or with plan hash, two views there, but use them instead, because when you query SQL, you're smashing some latching that protects the library cache. So your attempt to find out what's going wrong actually might make things worse. Whereas querying SQL stats is a separate memory structure. You can query that much more aggressively and you're not going to have dramas. So it's a really cool thing if you've got SQL queries to actually replace them with SQL stats where possible. But I digress. So this is what I saw. Before I went and found that string check procedure, the first thing I saw when I went to this customer site, I said, I run my query, and actually this is what I saw. This was the first clue that maybe something was amiss, is my standard query, I had refactored the buffer gets and executions columns too narrow to fit the size of the numbers that was coming back, because they were literally doing billions and upon billions of select substring from Joule, in-string from Joule. And this is where I went and met the customer. I said, we have an isNumber function. Like, why did you write a function called string check? And as people will know, in fact, or maybe people don't know this one, if you're on 12C and above, we actually have it natively in the kernel. You can actually do the validate conversion in both SQL or PL/SQL, which simply says, take a number, right, and it'll return 1 or 0, depending on whether something can be cast correctly. So you can see there p text in as number. I take that value, I say try convert it to a number and validate that conversion. If the conversion is correct, return 0, otherwise return 1. Might be the other way around, but either way, you get the idea. So that's a trivial way of doing it literally in C code. Similarly, if you actually want to get that number back if it is valid, then you can use the cast function. And all the normal functions that deal with string expressions or expressions that involve a data type conversion all have this now default on conversion error extension. So in this case, I take p text in as a number. I can actually say convert it to a number. If it converts fine, give me the number. If it doesn't convert fine, return me, in this case, for example, -1. But cast has that, toChar has that, toDate has that, toNumber, toTimestamp, etc. All these facilities now have the ability to return a default value as a flag of saying, yep, I couldn't do the conversion you requested. So those facilities are all there. In fact, even in before 12C, which when these really cool functions came along, you could still do it far more efficiently than that string check routine. This is probably the most common routine, and this is what I actually implemented for them to solve this problem. Take a number in, try convert it to a number, If I can't convert it to a number, then return 0, otherwise return 1. It's still a pure SQL call from SQL, and we'll talk about that possibly later on. But yeah, so it's still a pure SQL call from SQL, but it's far more efficient than doing 488 selects from Joule from within a pure SQL routine. The other thing of this is, of course, it's actually better. It's actually better than their routine, their string check routine. Because obviously if I was to pass in, for example, 123.45.789, I've got 2 dots in there. That would still be cast as valid because it covers the numeric digits, or the possible numeric digits in the string check. It's actually in the act of physically trying to convert something to a number that you can genuinely cover that off. And in fact, Ludith has just put on there, you using the translate function. There are similar issues with translate. Don't get me wrong, it's far better than their string check implementation. But still, you have that thing of, I can check if something contains numeric digits, but that's not necessarily the same as checking if something is actually a valid number. But either way, any option, almost any option I could think of would have been better than their string check routine. So of course, the obvious thing is I say, why didn't you use this? And of course the developers, I didn't know there was a ToNumber function. Well, they knew about ToNumber, but they didn't know how they could capture it to actually avoid the thing crashing. Their objective was to effectively preemptively see if something was numeric and not have it crash. ToNumber delivered by default without the 12C extensions didn't suit that need, so they thought they'd write their own. But I suppose the key thing here is, and as I said, I'm not trying to belittle the developer who wrote this, is the importance of load testing when it comes to looking for excessive work. Because that function works fine for 10 calls. It'll be, literally just a few milliseconds. It'll be fine for 100 calls, maybe 10 milliseconds. It'll be fine for 1,000 calls. It'll still be sub-second. What it won't be is fine for millions of calls. So it's so important to do some realistic load testing when you build functions that are going to sit certainly deep down in the core of your applications. Very, very important. Load testing is going to reveal when you have excessive costs that don't appear to be there, excessive work that don't appear to be there on first glance. This is my motto: infinity times anything is always infinity. It doesn't matter how cheap a single execution of something is, if you run it an infinite number of times, you're probably going to get yourself into trouble. I'd imagine people on the call now are probably going, well, thanks for that first example, but we would never do something. We're not that stupid. And it's very easy to be dismissive of other people's mistakes that are seemingly obvious mistakes in hindsight. But that leads us on to our next one. Let's talk about the hidden costs that might come when you're coding applications in the Oracle database. Costs that you think from first glance are zero or negligible, and yet might actually have a hidden cost that might come back to hurt you later on. Has anyone ever done this when they're writing application code? I need to know who's logged onto the database. And so we write something as trivial as this. I declare a variable called x, I begin, and I say x equals user. User's sitting there in the documentation. It tells us that user is a function call that gives us the currently connected user. It's a useful piece of information that we often might need. People might be thinking, well, I don't rarely call, not in trivial code like that. I don't just write x equals user. But let's build it up. Let's see how people can get into a state where they're calling pure SQL variable equals the user function, and why that might be a unseen or hidden cost that might hurt your applications. Let's build it up from ground zero. I'll create a table called people. I'm an active data modeler, I'm a DBA, I'm a developer, I'm building a new application, I need to record some people. So I'm going to create a table called people. It's got person ID, forename, surname, and as so many applications require, every time I insert a row, well, you better tell me who inserted that row. I need to know, for example, when it was created, who created it, etc. So we'll do something trivial like this. Created by a column, those extra what I call audit metadata columns that we so commonly add to tables. Created by, and I don't want to have to code this in my application, so default user. Every time you put a row in there, I'll put the default user in there. So far, so good. Of course, the very next sprint, the next scrum, the next iteration, insert trendy buzzword, continuous delivery tool, terminology here. I need to know, obviously, when someone changes that row. Now that I've caught when someone creates a row, what if someone goes and changes those person details? I need to know when that is as well. And so I'll follow that same mindset. I'll simply go alter table people, add modified by, and that'll be default user as well. So when we insert a row, both created by and modified by will both get the user, so we can assume that your first insertion is also the first modification. They're synonymous. And that looks promising until you've actually, of course, run the application. I'll connect as Scott, and I'll update one of the existing rows in the people table. I'm setting the address, someone's moved house, so I need to update their address. The person is 12345. And I've connected as Scott, so that's what I want to go in my modified column. And of course, when I select from the people table, I get a bit of a nasty surprise because it says it was modified by John. It wasn't modified by John. John was the person that actually inserted the row. And as most people will be aware, the great thing about the default clause on a column is that it applies only on the creation of a record. Updates don't go change default columns. I could explicitly have put in there in the update statement set modified by equals default, and actually the actual word default, a lot of people don't know that you can actually reference the keyword default to go pick up the defined default value. But as I said before, often we don't want that metadata to be the responsibility of the application. The application shouldn't have to go through and change all the code to explicitly set updated by, created by, etc. Now, if the application doesn't do that, what's the solution? Everyone goes, I know exactly how I can do it. I'll do it with a trigger, because then I don't have to touch any application code. A trigger can look after that for me. So I've got a trigger here called who did this row, and every time I insert or update, if it's inserting, I'll set the new created by. I could have got away with that without having the let me start again. I could have got away writing this trigger without capturing the insert, just focusing on just the update and relying on the default clause. But this is a common kind of code path I'll see. If I'm inserting, I'll set created by, and if I'm updating, I'll set new modified by. And that will solve the problem because now I've overcome that issue of default clauses only being applied during an insert statement. Here is a common mantra of mine. Infinity times anything equals infinity. As we said at the start, people very rarely code just PL/SQL variable equals user. But they'll quite happily code that same construct inside a trigger and think nothing of it. I've done a load test here, the importance of load testing. I've done an insert, select from lots of rows. So I'm doing, for example, a data load of the people table or etc. And I can see there, if we look at the execute line across at the right, you can see it says I inserted 80,000 rows and it took 8.5 seconds. 8.63 elapsed, of which 8.56 is CPU. This thing is a 100% just about CPU intensive operation. I don't care how bad your server is. There is no way known that an 80,000 row insert should ever take 8 seconds. That's insane. That's ridiculous. What was the cause? If I continue on through the trace file that actually captures this information, here's where we see a lot of the time, or a lot of the effort. I did select user from Joule, and you can see I did it 160,000 executions of it. That is the problem with using the user function inside PL/SQL. It just so happens that the user function is not natively inside PL/SQL. So when it sees the words user, it says, oh, I can't work that out myself within the realm of the PL/SQL engine. What do? I'll transparently rewrite that to a select user from Joule. That way I can get it from the SQL engine. So there's a whole lot of problems going on here. Number one is you're firing a trigger, which you probably would prefer not to run, but sometimes we have to. But within that trigger, I had to jump out from the PL/SQL engine into the SQL engine such that I could work out the user variable. That's a context switch. And you can see from the trace data there that it only cost 1.1 second of CPU and the overall response time was 8 seconds. The vast majority of the time wasn't actually running select user from Joule. It was the Peel SQL engine going, oh, hold on, I got to stop. I need to work out user. Let's jump over to SQL. SQL says I'm done. Let's come back. It's the flip-flopping that actually cost you all that time and CPU. That takes code path, takes code cycles. You might be thinking, well, how do I avoid that? I need to capture the user information. I need that user details. How do I catch that information? Well, we just need to think a little bit outside the box. There are mechanisms in Peel SQL to extract information about your session that don't involve a transparent rewrite to select from Joule. One of those is the syscontext function. So if I make a call to syscontext from Peel SQL, that's implemented natively. So I don't need to jump out to the SQL engine to do it. Session user gives me the same information as user. So simply replacing your calls to user in Peel SQL with syscontext, you're going to get a dramatic improvement. I'm not saying that everything you have should be replaced with syscontext. What I'm saying is, as a general rule, whenever you use any supplied function inside a Peel SQL trigger, do a quick trace on it, see if there are any select from Joules in there. If there aren't, you can be confident that it's natively implemented, because it depends on your version. Syscontext also used to implement as syscontext from Joule. The UID function, I think, still does a select from Joule. Sysdate, up until about Oracle 10, used to do a select sysdate from Joule when used within a trigger. So over time, more and more functionality has been implemented natively in Peel SQL, and therefore very useful in triggers, but it depends on your version and possibly depends on your platform. What's more important is not knowing which ones do and don't, it's the ability to make sure that you always trace your code, find those hidden costs. If I rerun that same execution, the 80,000 row insert, within the triggers still enabled but using syscontext, notice my time has dropped from 8.5 seconds down to 0.68 seconds. Believe it or not, that's still pretty slow for an insert because the trigger is on there. But if you have to have those triggers, if your application requires them, mandates them, then I'd still much rather have a 0.6 response time than an 8.6 second response time. Avoiding those flip-flops back and forth between the Peel SQL and SQL engine are critical in triggers to make sure that you don't get that performance hit. So as I said, regularly check your triggers in your code, do some tracing on them to make sure they're not invisibly rewriting your code to doing select from Joule, because it's going to punish you. And because all SQL from Peel SQL is normalized, you'll see it in uppercase in $SQL, it's pretty easy to check $SQL stats to see if you've got a whole stack of uppercase versions of select something from Joule. If that's in there, there's a very good chance that it's actually some invisible function in Peel SQL that is not yet implemented natively, that has been implemented by doing a select from Joule. Let's get on to number 3. The next, quick drink of water. I'll keep an eye on the time. 9:30. What? Dear, oh dear. To use a pun on words, Christmas is coming. The mistake of wrong data. And obviously, we are database professionals, and let's shrink that term down to database. Our jobs, our fundamental jobs typically are to make sure our base of data is backed up, recoverable, has integrity, and is correct. That's one of the most important things. So the wrong data is probably the worst mistake we can make. And triggers are a common cause of that wrong data. I know I just said you might have to have triggers in your application in the previous mistake, but you need to be very wary of them. Why are triggers a possible cause of wrong data? It's the most common reason I see for people corrupting their database when they implement database functionality in triggers. And let me give you a true story on this one. I worked with a customer because they asked me in to say they actually suspect that there might be a bug in the Oracle database. We've written an application, we've tested it, it works fine, all our developers can't fault it. When we go live, we have dramas, we have data corruptions, we think something is going wrong in the Oracle database. Don't get me wrong, I'm not claiming that the Oracle database in all versions is always perfect. We occasionally get wrong results, etc. So I always go into customers with an open mind when people say this. I've simplified their data model to this very simple example. They have manufacturers, and manufacturers make products. So the manufacturer is a logical parent to a list of products. That's the data model. That's the only elements of the data model we're going to focus on in this particular example. As you'd imagine, the logical thing to do here when you have a parent and a child is you add a primary key to the parent table and you add a foreign key to the child table, which points back to the parent. It's funny how some of the more modern databases still to this day are talking about, oh yes, we hope to have foreign keys and referential integrity in an upcoming release. Some of these new modern distributed databases, etc. It's amazing that I don't know how I could survive in a database without referential integrity. It saves your bacon so often. But I digress. They didn't do this. And to explain why they didn't do this, they weren't unfamiliar. They were actually fully cognizant of the fact that Oracle database had a nice, robust foreign key implementation. They had originally had foreign keys and primary keys, but they'd had to make some adjustments as their application had evolved. If we looked at their table structure, initially they started off with a manufacturer table, where, as I said, it had a manufacturing ID, that was their primary key, and their product table, which is the child table, had a foreign key, manufacturer ID as well, linking back to the primary. That's how they implemented it, just like we normally would as data professionals. We have reference integrity, foreign key back to primary key. Their application requirements had changed over time. Whereas a manufacturer used to be just an instance of a manufacturer, they needed to deploy an application enhancement which included some temporal validity, i.e. a manufacturer had versions. So they actually had to change their data model to say a manufacturer actually has a version. What do I mean by a version? It might be, let's say my manufacturer name is, John's Car Tires. That might be my details, and I might have my address, and I have my details and what my credit score is and all sorts of things like that. When that changes, these people who build this application needed to keep a previous instance of those details for historical reasons, such that that could link to historical products. When this product was built, this is what John's details were, this is what his address was, this is what his credit limit was. But now, as a manufacturer, I've evolved to do something else. I might make other products, I might offer other services. So they introduced a manufacturer version. So the same manufacturer could occur multiple times in the manufacturer table, being a representation of temporal validity, a version of including a start and end time of a manufacturer's details. Of course, for some tables in the application, they needed to now refer back to that pair as the primary key. They want to record some details based on the particular instance of this manufacturer row. Whereas lots of other tables, including in this case the product table, only need to refer to the actual existence of a manufacturer. We don't care what particular version it is, it's actually just the manufacturer ID. You probably are aware already that we probably should have implemented manufacturer as two tables, a base manufacturer and a manufacturer instance to capture the temporal validity, but of course that's more work, time, money, budget, effort, blah, blah, blah. We all live under real-world constraints. So they altered the primary key of the manufacturer, but they didn't want to alter the product definition. That means you can no longer use Oracle standard primary keys because we now have a discrepancy between the foreign key linking back to the primary. No problems, they said. If we can't use Oracle's referential integrity, we'll just build our own. And the best place, obviously, to put that would be in a trigger, because then it captures the essence of RI checking right down in the core of the database. And so they wrote this code. Here's the first bit. Every time you insert or update a product, which is a child row, you can see that the first thing it does is do a select manufacturer ID from the manufacturer table. And that's what referential integrity is, isn't it? Every time you change the child, check the parent. Make sure you're doing something with a valid parent, and otherwise spit out an error. Obviously, we need to do the opposite, which is every time you want to delete a manufacturer, well, there better not be any child records for that parent. They could have implemented this with delete cascade, but ultimately, that's typically not what you want to do. Typically, the most safe option is you try and delete a parent, you better make sure your job is to delete the children first. So you can see what they did there in this trigger. Every time they delete a manufacturer, we go check, are there any products for that manufacturer? If there are, then blow up and say you're not allowed to do a delete. And here's the thing. Testing of those two triggers works a treat. Let's actually run some tests. You can see it. I said insert into product, valid manufacturer of 100. That worked fine. Insert into product, invalid manufacturer of 101, and I get the error. So I've ticked off the foreign key in one direction test. I tried delete a manufacturer where a manufacturer actually has some products. I get the error I'm expecting. The manufacturer is in use. And here's the key. When you build things in triggers to do referential integrity, testing generally works. And then 1 month later, which is the point at which they called me, their application was crashing all over the place. And to prove, they said, I'm going to prove to you there's an Oracle bug. We've got these triggers in place, and yet when we do this query, which is show me all the manufacturers in the product table, which cannot be linked back to a parent, there were 86 of them. And they're saying, this is surely impossible because our triggers are forcing this not to be the case. Our triggers are guaranteeing that you can't get into this situation where you have orphan products that don't belong to a valid manufacturer. The fundamental here is generally, unless you are super careful, do-it-yourself data integrity is pretty much equivalent to no integrity. And I know that's a fairly sweeping statement, but it's so true because the kind of code you do, it seems easy. Those two triggers was trivial code and it seems to cover all the use cases. But it doesn't, because all you have to do is turn this into a real-world application timeline. If time goes from left to right, as you can see on the screen, I might create a product with manufacturer equals 7. Manufacturer equals 7 is a valid manufacturer ID, and so I'm allowed to create that product. Further on the timeline, some other person comes along in a different session and says, I'd like to delete manufacturer 7. The trigger fires as it's meant to and says, is there a product with manufacturer 7? And there isn't one yet because the session underneath the timeline is yet to commit. So that delete will be allowed to occur. Bottom session under the timeline commits, top session commits, and hey presto, we have a data corruption. There is the first of our 86 orphan manufacturer records or orphan product records. It's so hard to do data integrity in a multi-session, multi-user system. Triggers don't cut the mustard unless you are responsible for all the locking, etc. It is so funny, data integrity seems a trivial thing. Before I do this to the parent, check the child. Before I do this to the child, check the parent. It seems trivial. It's actually really, really complex to do. It requires all sorts of specialized locking and even some cheats inside the kernel to implement it well. Doing it in triggers is a recipe for disaster, hence the mistake of the wrong data. If you're a pure DBA on this call or watching this video, you're going, not my problem. That's a developer issue. They're meant to look after that. Developers are meant to write code that doesn't cause data corruption. But it sneaks in everywhere. And it's so funny how the kind of things that we often write as DBAs can often get ourselves in similar trouble. And I'm not talking about coding triggers here. You can get into trouble here with no triggers at all. Let me present to you an example of a trivial requirement. I need to copy my employee table from my OLTP system every night, every hour, etc., every minute, depending on how real time I want to be, to my data warehouse. And it might not be a proper data warehouse, it might just be a staging area, but I simply want to copy a table from my employee table to somewhere else. Now, I could do it with Golden Gate, I could do it with streams, or change data capture, but all those things might involve complexity, might involve money, and so often we think, how hard can it be? I'll do it myself. And let's see the kind of things that can go wrong when we do this. Now I need to do a new share here, but I need to get two windows up, so bear with me while I try to sort out the mess here. Okay, hopefully everyone can see two windows on screen. Please sing out in the chat line if you can't, but hopefully you have two SQL Plus windows here. Now I need to remember what the demo is going to be. Yes. So I'm going to copy all the rows. I have my employee. Let me start again and actually complete a full sentence for the people on the call. I need to copy all rows from my employee table to a clone of that table called the employee table on my data warehouse. And I want to do it every hour, every minute, etc. So the first thing I'm going to do is create my employee table. You can see there, I've got created one. It's a copy of some data from all objects. There's just 1,000 rows in my fake employee table. Even though it's only 1,000 rows, if I'm going to be doing a transfer every minute or every 10 seconds, whatever, I don't want to copy all the rows over every time. I don't want to be comparing all the rows. I just want to pick up the changes. So what I'll do is I'll add a column. You can see I've done alter table, add, modify, row creation, default sysdate. So every time I put a new row in there, and I'm going to make this very, very simple. I'm not even going to worry about updates yet, so there's no triggers. Every time I put a new row in there, we're going to add this row creation value, which tells me that I've added a new row so I can pick it up. If I'm going to pick up just the changes since the last time I ran this routine using the row creation table, I need some sort of control table, and that's what this one is here. I've got a control table here. When's the last time I ran my job to copy all the data over? And it'll be sysdate from DualWits right now. Let's go to another session and continue building our demo. I'm now on my data warehouse. So to start off with, let's create our emp warehouse table as being a copy of employee. That gets the two tables in sync. Let's assume this is an application outage. So we have the two tables are now in sync. And here's my routine to actually copy the rows over. Pretty simple. Copy new rows, insert into the employee warehouse table, everything from the employee table where someone has inserted a row more recently than the last time I ran my job. Now that I've done that insert, update the control to say, yep, I'm done. Effectively, I'm up to this point in time, and commit. So we grab all the rows in the last 5 minutes, and then we simply move our timestamp along and we continue on. Nice and simple. Let's make sure now that actually all our stuff is actually in sync. So I can do this query, which is all the warehouse rows minus the employee rows, and all the employee rows minus the warehouse rows. So I'm looking both directions and make sure there's absolutely nothing out of whack. They're perfectly in sync. I insert a new row into my employee table, and it's me. It's a value of new employee called Connor. Here's our job on the data warehouse. It says it's time for our schedule update every 10 seconds. Copy all the new rows. Everything's perfectly in sync. Looks fantastic. Everything looks fine. Let's go back to session 1. I run a commit, and it's that same timeline issue. Even though no triggers here, simple routine. And you can see when I do my comparison now, I'm now out of sync. I've got one row here, employee number 1, me, and he didn't get copied over. Now you think, oh, that's not a problem. You think, I'll copy it over next time, the next time I run. But look at what we've done as a result here. The row creation time was here, 21:47:51. Our last run is 21:47:59. The next time we run this, we're going to pick up all the rows from 21:47:59 onwards. This person here won't be picked up. This row will be missed. He's dropped out of that sliding window of time. And unless I've got some complexity here, he'll always be missed. Now, if I then go back and say, well, let's go back and look for previous ones, well, then I've now got huge amounts of complexity because now I'm back to looking at the entire table. It's actually a non-trivial task to simply copy rows from one table to another and try to keep those two things in sync. So that's an example of it sneaks in everywhere, that in the most trivial things of all I need to do is copy some data. If you're not cognizant of Oracle's read consistency model, whether you're using triggers or not, it's so easy to get the wrong data. Very important that you take care. I suppose all I'm saying is when it comes to writing code where people are actively using your system and you need that data integrity, you just need to be careful. You need to explore what the locking mechanisms are. We might dedicate a session, another YouTube video to that one day to talk about how to avoid these issues. But I suppose the takeaway message given this video is let's make sure we just be careful that we don't unintentionally add data corruption into our databases. Let's take that to the next level. Let's not just talk about the wrong data, let's talk about the wrong data type. The mistake of the wrong data type is rarely one that causes data corruption in a database, but what it can do is cause all sorts of performance dramas in the database. And here's one of my favorite quotes from my predecessor, Tom Kite, good friend of mine, worked on Ask Tom obviously. Amazingly, the date data type is a good one to use for dates. And here's why I wanted to talk about the date data type in particular. And it pertains to how the optimizer works with the database. Now, before I talk about the optimizer, let's talk about humans for a second. For humans, cardinality is everything. Now, what do I mean by that? You, I imagine, are just like me, we have to go shopping from time to time. Those of you who do online shopping, I have nothing but disdain for you. But I like going to the shops. I like getting the basket. I go to the shop and I grab some things. And of course, when you get to the checkout lane or where you have to pay, you don't just walk up to, like you can see on the screen there, you don't just walk up to line 10, because for a start, there's no one manning that one. But even if there was, what you do is you act like an optimizer. You scan along, you have a look and you're saying, okay, what's the best option for me? I've got lane 10, 11, 12, 13. What's the best one for me? What's going to get me out of here fastest? And you might see, lane 18, there's just one person there. Looks like they haven't got much. And you sprint down there because you think that's going to be the best option. And of course you get there and that one person, if you're like me, always, that person has the trolley from hell. They've got a million things, or the trolley looks empty, but they're all like they've got 5,000 little tiny items, and you're going, oh, there goes the rest of my afternoon waiting for this person to get their shopping paid for. It is exactly the same for the optimizer. As a human being, I made an estimate. What was the best option for me? It was aisle 10. If the reality does not match that estimate, if the estimate was bad, I thought I'd be through there fastest, but I was wrong. That's when the optimizer goes wrong, just like human beings. If the estimate doesn't meet reality, that's a disaster. Bad estimates means bad plans. So how does it come back to the wrong data type? Well, let's do one last demo. We've still got a little bit of time left. Let's do another demo looking at what happens when we don't use smart data types for dates. So let's do a new share. Hopefully we can all see that. So to show you the issues with the most common mistakes we see when it comes to data type selection, I'm going to create some tables. The first one is string date. So I've got a column here called X. I'm going to store some dates in them, but I'm going to store them as strings. I've got a table called number date. A lot of, especially third-party applications which want to be database independent, will store their dates as numbers. And you can see on line 5, as for line 4 and string date, I'm storing them all as YYYYMMDD. So I can store them as strings, or I can create a table called number date, which stores them as numbers. And I can have a table called real date, which unsurprisingly, I'll store that same information, the exact same data in all three tables, but the last one, I'm actually storing it as a date. Let's whack some indexes on so everything's in alignment. And we can see they actually have the exact same data, just in different data types. On string date, we start at 1995 and we go to the year 2206. So 2206, that's a couple of hundred years from now. And the same in number date, the same in real date, etc. So the data is identical. Remember I said, bad estimates, bad plans. And here's where the wrong data type when it comes to dates can be such an alluring but damaging thing. Let's start with this first query. I'm looking for all the dates between 2005, 7th of January, and 2005, 14th of January. So it's a week, 7 days. The optimizer came up with an estimate of 2. It's not perfect, but it's reasonably close. A couple of days, 7 days, it's not years, we're pretty good. Let's look at the number date, pretty much the same estimate, 2 days for the same deal. When I look at real date, it's not correct either. It didn't come up with 7, it came up with 9. And here's where the justification often stops. I'm looking for a week in January, string date was reasonably good, number date reasonably good, real date about the same, maybe a touch better, but therefore who cares? But here's where things get so damaging in applications when you don't use the right data type. Let's now look at 31st of December, the year 2000, 1st of January, 2001. So it's a single day. And I've chosen an example where it spans a year. It doesn't really matter whether you span a year or span a month. Obviously, the database has no idea about that kind of information if you're not using a date data type. So now the database thinks you're 326 rows. Now that is miles out. Let's look at the number table, same issue, 326 rows. And unsurprisingly, when I look at the real date, I'm pretty close. It's a 1 or a 2 day differential, depending on how you want to phrase it, and I'm in the ballpark. And this is where non-date data types to use for dates are so bad, because they'll be great for some days and horrible for other days, and you'll never really know. It's when they cross those invisible boundaries of months, weeks, etc. So critical that you use the right data type. You might be thinking, well, maybe I just need to add some more statistics on those things. So let's jam some full histograms onto string date and number date. That might help you, but in this case, for example, looking at that same example of one day, the string date got a little bit better, went from 320 rows to 263, and the number date didn't get any better at all. So it's so critical to pick the right data type. And we could do similar examples here where the critical thing is a number and someone used a string, or the critical thing is a string and we used a number. It doesn't really matter. The key thing is choose the right data type for the right job, and you're generally going to have a much happier optimizer. If you've inherited an application which has strings for dates or has numbers for dates, you might not be able to control the application code, but what you might be able to do is add virtual columns which transpose that information to a real date, and then your own code, your ad hoc reporting, Apex applications, etc., they might be able to use the virtual columns which will be stored as the correct date data types. If you're worried about that breaking the application, then what you can do is you can make those virtual columns invisible as well. So the application will never know that there are extra columns added, but your reporting, your views, your Apex reporting, etc., will be able to take advantage of correctly data typed columns. I suppose the underlying message here is if you use the right data type, you'll have far less problems. Reinvention. Do we have time for reinvention? Probably not. Okay, because it's the last one of the year, I'm throwing this out one. I'm throwing this out there. You need to speak up now on your chat. We can either call it quits here with 2 minutes to go, we can wrap it up, or we can do one more mistake, which will probably take us, I reckon, to about 5 or 10 past the hour. Okay, sing out now. We go, please continue. One more. Keep going. Okay, we're going to look. The first 3 votes have come in. I got nothing better to do. It's nearly Christmas. Let's keep on going. Okay. The mistake of reinvention. What do I mean by reinvention? APIs are good, right? You know, anyone that's been unless you've been living under a rock for the last year, has seen that, it's all about microservices and API and functional programming. If you want to be one of the cool kids, you've got to have the word API somewhere in your resume, on your code base, on your GitHub repository. It's all about APIs. And we've known this for a long time in the database. If you've ever been on any presentation or white paper blog post about SmartDB, it is the fact that SQL just floating around out in your application universe is generally going to be much harder to manage and much less performant than if you can consolidate SQL into pure SQL libraries. And this is the example I have with a customer that said, we've been trying to follow your advice, not necessarily mine, but basically, as an Oracle practitioner, we've been trying to follow the right practices. We have a Java application, there's SQL everywhere. We've been pushing that SQL into pure SQL routines because we've been told it's the right thing to do. But we're having problems, so I went and visited them, and the first thing I said, well, show me some of these APIs. And we simply went and looked at user objects where the object type was function, and you had some examples that they had get answer name, get assessment name, get gem. They had dozens and dozens of functions, and I was actually already pretty chuffed, because it's a big challenge nowadays sometimes to get people to embrace pure SQL. They're like, oh no, I'm going to do it in Node, I'm going to do it in Java or whatever. It's hard to get people to say, yeah, there's intrinsic benefits to having your code tucked down in pure SQL. So I was like, yeah, we're on a winner here. I went and grabbed one of these things and said, well, let's see what's in this code. Maybe it's just badly written or bad SQL, etc. But they were all very clean, neat pieces of code. For example, I picked the one get gender name. And so you could pass in an ID, which is like the primary key of the gender, and you could get the name. So you could take in a meaningless key, the surrogate key, and you could get the meaningful piece of information back. So ID 1 could come in and gender might come back as male, ID 2 female, etc. That was most of their functions. Take a surrogate key, get some meaningful data back. And it sounds good. You know, so far I look at this customer, I go, okay, you've been moving your SQL out of Java. Fantastic. You've been building APIs in Pure SQL. Fantastic. The code looks neat and clean. It all looks good on the veneer, on the surface. But it suddenly dawned on me, I said, but users never enter keys. A user never types on their application, I'm interested in primary key 1784932. They just don't do that. A surrogate key they are blissfully unaware of. That's why they're surrogate keys. So if users never them, what uses these functions? And it is an all too easy trap to think, well, what I need to do is move things into Pure SQL. So this is how their Java started. Their Java was, okay, I'm getting some information from the person table, I'm getting their last name or their full name, and they're getting their gender ID. But the gender ID is useless, so I'll make a call to my Pure SQL function to get it. And to their credit, they went, this is not a particularly intelligent way of doing things. You know, I can do it all in one SQL. I'll just do this. Select ID, first name, and why do a separate call? I can get it all in one SQL statement, get gender name. And that seems good as well. And then they said, well, we can take this to the next level. I've got lots of different surrogate IDs on, and this was actually a hospital application. So I've got patient details, I've got the gender ID, the suburb. So I've got get gender name, get suburb description, get hospital name, etc. So with the best of intentions, they've moved SQL to Pure SQL. They've consolidated definitions, and they're writing views to expose that information out to the outside world. And it's like, you know, if you've ever seen the Avengers final movie where they do some experiments on a computer, they go, hey, time travel, yeah, look what we've invented. Well, this customer was the same. They were very, very excited, but what they'd really done is simply reinvented the join. That's all they'd achieved. Because if users never enter surrogate keys, the only way you're going to use those functions where you pass a surrogate key in to get a value is from one table to another. They've reinvented the join that the database provides. And here's where their performance problems lay. When I did some tracing and some explain plans, these are the telltale signs that you too can use when you're looking to see if someone has reinvented a piece of Oracle functionality. They would do select from patient details, this view that you saw in the previous slides, where hospital equals Princess Margaret. It's a hospital that used to be up the road here. And there's no clue from the plan. The plan will never tell you that it actually had to do a whole lot of other stuff. But the key is your stats. When you start seeing recursive calls, that normally means you're doing a lot of parsing, because parsing involves recursive calls. But once something has been parsed, if you still see a lot of recursive calls, that's a telltale sign that you're probably calling, for example, a Pure SQL function, which then does more SQL inside your base SQL. So if you look for high recursive calls on your stats, that's the telltale sign that perhaps things aren't correct. And you can see 92,000 consistent gets, all of which in these recursive calls. If I simply rewrote the thing to do a join, which is of course what databases are designed to do, the thing was then 88 consistent gets. So I really felt for these people because they literally simply misinterpreted a really excellent philosophy and piece of advice in terms of consolidating code, putting it in Pure SQL. They just walked down the wrong track. If someone had discovered this early in the piece, I'm sure they would have came back along the right track. But they had a huge refactoring exercise to sort out this. So things to look for. If you're having performance problems and you want to see if developers are reinventing database functionality, the ones I most commonly see are aggregation. The amount of times you'll see a code which loops through a cursor and simply says, oh yeah, I'll add things up as I go. Like it's the sum function. And if it's more complicated, it's normally a sum analytic function, but it can be done in SQL. And as an example here, joins. And the thing that leads developers astray, and as DBAs, you really want to be involved here and try to help them on that journey, is the module specification. because often the module spec will say, go get each person for some criteria, and then check their gender, check the hospital details, check this, check that. And each one of those will be some piece of code that probably already exists, and the developer goes, code reuse is good. And we head down that path of looping through and inventing the join. So aggregations and joins are the ones that you really want to be on the lookout for and avoid that critical mistake of reinvention, because the database is generally going to do it better than you can. Thank you for staying on. Look, it's only 6 minutes past. Let's wrap it up. I reiterate, as I did last month, the importance of failure. When we discover customers, even if the customer is ourselves, when we discover things that we did, and as hopefully I've stressed today to you, is people did it with the best of intentions, but when we make a mistake, let's broadcast it to the world. Let's make sure that no one else makes the mistake, and I think it actually cements our position of sharing information with the community, not just bragging to the community. We're actually sharing our successes and our failures with the community. That's the important thing. We are done. Thank you for those that hung around for the extra 7 minutes. And I know I've lost some people on the call, but I do want to say just one thing before we wrap up or final off. Thank you very much for your support for office hours, not just DBA, of all the different office hours for the year. From behalf of myself and everyone on the Office Hours program and the Ask Tom team, myself and Chris in particular, please have a fantastic, happy, safe and festive season. I hope to see you at a conference or virtually online next year. As I said last year, on the very start, same last Office Hours, I said, please don't do any deployments next week, because the last thing you want to be doing is logging on to your parents' Wi-Fi at your family gathering, trying to solve production problems. No deployments next week. Just take the time, take the relax. Even if you are working, nothing serious. Have a fantastic Christmas and best wishes for the new year. I'll see you all in January, hopefully. Bye for now.